afternoon, and thank you for joining us for PlasCred Circular Innovations first webinar with Adelaide Capital. PlasCred has developed a patent-pending technology that could be a key to assisting in the upcycling of used plastic into reusable products as opposed to just ending up in landfill. PlasCred trades under the ticker symbol PLAS on the CSE and MGPRF on the OTC. With us today from the company is President and CEO Troy Lupul. There will be an opportunity for questions after the presentation. Please enter them in the Q&A box. As always, the presentation may contain forward-looking statements. Welcome, Troy.
Good morning. Thank you for having me.
Do you want to just give us a little on your background to start and how you and your team came up with this ingenious way to use plastics?
Yeah, one of the unique things about history, my background obviously is processed water, and I was dealt with a lot of different projects around the world. And one of them was to take microplastics out of water. The unique thing about it, what I found was no one was dealing with the plastic once you removed it. And as I dove down into the world, it was amazing to me how much plastic is not recycled on the planet Earth, less than 9%. And as you know, oceans are accumulating large volumes of plastic. This is allowing, what I see as a huge opportunity to actually take that, because it is a petroleum product. It is a hydrocarbon. And basically with our team, in an overall view, is we were able to take that plastic and convert it back to original Mother Earth molecule.
Okay, great.
So what's really been great is we've put together a really good team that is a veterans of very large projects, throughout the world. And in obviously the oil and gas sector, myself, Wayne Monnery, who's our CTO, who basically has done amazing projects around the world with different types of refineries. We have Brian Hurst, which is our CFO. And also we have a couple other individuals in our engineering department here that have absolute big depth in basically pyrolysis oil treatment, as well as different other types of processes. So, and it's been really exciting, because I think one of the things we've been able to do is put together a team that has done very large scale projects, but also been very successful in doing unique projects as well. So that's been really good about our company. We've got a fantastic board, James Caron. I can't stress logistics with PlasCred is just phenomenal. We got James Caron from CN on the board. He was very instrumental on movement of volumes of plastic to our location. And then also Jerry Jelowitz, which currently is the CFO of Journey Energy, which understands, obviously the costing per barrel. And myself, which obviously I've built large companies before, Filterbox, Clearback, and I've worked around the world with different projects for water treatment, as well as different processes as well.
Yeah, the one thing you said to me when the oil and gas market went to hell, you started focusing on this, and that's how you came about with the idea and started working on it.
That is correct. Yeah. That is very correct. One of the advantages we do have is that when the oil and gas sector did go down, we had a lot of talent sitting against the sidelines, so we could take advantage of that. That allowed us to really put a lot of good brain cells and towards our technology, which has been well above our expectations. And we're really excited about that. But once again, all good companies, come together with great teams, good people who have skill set, good game, understand the goal, and have a clear line of sight of what we're doing.
Okay. So let's get into plastics, because that's a key area. And like you said, only 9% of plastics are actually recycled, as much as people go to their blue bin. It's not being used. Just to touch quickly on, what's happened with the UN and the Ellen MacArthur Foundation, which is, they've made an agreement to start a circular economy, a few years back. And your company's perfect in repurposing plastics for the circular economy. So I'll let you take it from here on your plastic usage.
One of the unique things about the human society is we need plastic. We need it for carrying our products. And, you go into any grocery store. But one of the things is really bad is because plastic comes in all types of species of plastic, meaning from C1 to C7. What does that mean? Well, your milk jug is completely different than your Tide bottle. And most of the time, what we've been doing as nations, especially developed countries, we've been exporting our plastic offshore. The kids in the third world basically sort it out, and then the rest goes into the never-ending landfill, which is called the ocean, which is triggered by the tsunamis. So it's been unbelievable how much plastic is floating in the ocean. But it's not just that; it's the fact that it's easier for us to either landfill it, burn it, or basically farm it offshore. And this is what's allowed us to accumulate these, very large deteriorating volumes of plastic.
Well, and I think oh, sorry to interrupt. I was just going to say another key thing is that there's now laws in the EU and multiple states for companies that need to use a certain amount of recycled plastic within their products, like Coca-Cola, Pepsi, etc. I mean, it's a huge problem, and here you offer somewhat of a solution. So.
Yeah, I think we've really changed the world in regards to what we're doing because you can only mechanically recycle something with 20% recycled plastic. You need virgin feedstock. And the virgin feedstock is cheaper than trying to recirculate a mechanical piece of plastic. It's just not working. And the logistics is too hard. Well, we looked at the problem more from a global scale, and we wanted to take all the species of product of plastic, but we really focused in on unrecyclable type materials that were like the worst plastic that sat out in the ocean for 20 years, the worst plastic from the chip bag that wound up on the beach. We really focused on trying to take that piece of hydrocarbon and convert it back to its mother earth molecule. And that's really where our technology shines. So this is why, when it looks at, plastic, we're going to be able to take high volumes of plastic. So it's really made a differentiator compared to anybody else in the world.
Okay, so let's just talk about what your plans are for your plastic usage.
Yeah, basically, we've come up with our own reactor. It's a patent pending process as well as a reactor. It's allowed us to take all kinds of species of plastic, and it's really phenomenally designed and engineered more from an oil and gas perspective. We basically are washing the plastic, grinding it down, getting it into a scale. And our first plant, we're going to be making a finished product called zero sulfur green condensate. This allows us to repurpose that molecule further upstream, like really upcycle it right back to, instead of drilling wells, we can repurpose that molecule round and round, unlike mechanical type recycling. The other big advantage is our scale. Because we've designed it in our design, we can go basically to 2,000 to 10,000 barrels a day. That's huge. So our first phase is 300 tons of plastics per day of all mixed species. And then obviously we'll scale up to 10,000 barrels, which is about 1.3 tons a day of waste mixed plastic. So that's like from car parts to Tide bottles to medical waste to diapers, you name it. Anything that's hydrocarbon based, we can turn it back to its original molecule.
And from, the C1 to C7, C1 being food grade, are there any plastics that work the best, or all of them work for you? And do you get better yields from different kinds of plastics, or?
Everything works extremely well. Surprisingly, the chip bags and the stuff that's been the worst actually works. We've had the best reactions. The only thing is we have PVC, polyvinyl chloride. Those basically, we have a unique system within our plant. So if large volumes of PVC do enter, we have a separate two-phasing ability to take and get rid of that. So, but we can take the whole spectrum. And that's why we're really excited. We can take all the species of plastic and be able to make a finished product, which is basically a repurposed molecule.
Okay, so let's touch a little bit on the condensate market and why you get a premium for your condensate, et cetera, and how your location is key.
So the market for condensate in Alberta is over 1 million barrels a day, which is, runs at about anywhere between, $120 to $100 a barrel, depending on WTI prices. The big advantage of building the plant here in Fort Saskatchewan, where you look at the map, is we're in molecule country. This condensate is in huge demand. We're importing 200,000 barrels a day from, the United States. But what's really unique about our high quality condensate, it has zero sulfur in it. So it actually improves a lot of the processes So we can send it back to a steam cracker. We can repurpose that molecule, and absolutely, whether it goes back into building your new Tesla dashboard, whether it goes into making your new cell phone, we're further upstream. When you pull your TV out from Costco, we have Dow polystyrene. We can repurpose that molecule back to there to make more polystyrene. The whole idea is to create a circular, and I'm going to say very far upstream type circular economy that is done at very large volumes, not, a couple thousand barrels here and there, but our goal is to get to 10,000 barrels. And as you can see by the numbers, it's a drop in the bucket. So 10,000 barrels a day for us is nothing compared to the over 1 million barrels a day that's currently being used. So we've got a huge market, unbelievable market right there.
So let's talk about the different phases you're going to. You have your pilot plant that you've started.
Yes.
And when was that started?
That was started last year. We were able to basically provide third-party data analysis on how the raw mixed plastic was being able to be put back into a product. And also, we've basically been able to capture data that is engineered through our EPCM Grail to basically verify the product and also the technology. So we're really excited. We've got a viable technology that no one has, and we're really excited about that.
And so you've done multiple runs with Primus, and you doing third-party testing in labs as well for different grades, et cetera. Is that correct?
Yeah. So we've been basically been able to take all the mixed plastic here, and as you see, it's your Tesla dashboard, your milk jug, your Tide bottle, but not just that, but it's industrial waste. So you're talking medical, everything you can think of, and then our finished product here, which is zero sulfur green condensate. So this
looks like condensate to me. Yeah.
Yeah, it's a nice light, and right now that sells today as we speak for about $100 to $110 a barrel. So this molecule here can be repurposed, and remember, it doesn't go into transportation fuel. We're not burning it. We're not doing any of that. It doesn't go back to We're not trying to do plastics to fuel, which is a technological success. We've made it simple. We've been able to take this and make it into this. Super simple, easy, less cost, low energy, and be able to have a finished product that we can go make more products out of, such as, Tesla dashboards or cell phones or computers or whatever.
Or even just to make it more simple, mix it with heavy oil to make it pipeline spec.
Yeah, absolutely. Absolutely. Yeah. And that's even, so we've got loads of customers for our finished product.
Yeah. No, I was just going to say, certainly where you are, the demand for it. Your main customers would be heavy oil producers, midstreamers, et cetera.
Yeah, exactly. It's exciting. We're having a lot of fun here at PlasCred.
Yeah, no. So let's take a step back and just dumb it down for people first seeing the story a little bit. So you've got Primus done. You're continuing to run. You're talking to different end users of your product. When do you get to the phase 1 point of Maximus? So the first 2,000 barrel a day plant.
So currently right now, we're shovel ready. We want to build Maximus. Our primary goal is to select a site. Once we have the site in the heartland, which is around Fort Saskatchewan, Alberta, then we'll be moving forward with the plant itself for financing. And then basically our build cycle is between 18 to 24 months to build a 2,000 barrel a day plant, which will allow us to take in 300 tons per day of raw mixed plastic throughout Canada.
And then you can do these bolt-ons. And I know you haven't done your feed study. When do you expect to start your feed study?
As soon as we select our land, that's going to be key, because then it shows the logistics of how we're doing it. Really fantastic. The bigger you build, you get the good economies of scale. The price per flowing barrel reduces.
Your economies of scale improve. Yeah.
Yeah. So we're really excited to get to 10,000 barrels right away.
Okay. And I can't hold you to these numbers since you don't have a feed done, but what would be the estimated initial cost of your 2,000 barrel a day initial plant, and then the bolt-ons, and then what are your operating costs?
Yeah. So for instance, if you look here at 2,000 barrels a day of finished product, we'll be basically looking at about 120 million Canadian for that 2,000 barrel a day. And that'll be an 18 to 24 months build cycle. And what's really good, as we get the economies of scale, you're looking at about a $50 to $55 million expansion just to do the extra to go to 10,000 barrels. So it really drops in price once we start getting into our first phase. So you get really good economies of scale with our technology.
And easily debt financed with the take or pay, I would think.
Yeah.
And one thing you started to touch on a little bit is just that there's been many other companies out there trying to make, renewable diesel, renewable fuels out of biomass, out of, corn oil, things like that. And I think it's important to touch on the differentiating factor of using pure plastic and what those other companies are doing and why it's not been successful at scale for them and it can be for you.
Yeah, and that's a really good question. I like that because we set out not to make a transportation fuel. I could take this and upgrade it and upgrade it and upgrade it and upgrade it, and I will be successful. And it's a technological success, but I have to throw a ton of money at it to make this an ASME grade diesel fuel that you're going to be willing to put in your truck or car or whatever. We looked at it from our lenses that we knew our feedstock's going to be variable. We knew we got to take everything. We've got to take the bale bags from the farm. We've got to take the Depends diapers. We've got to take every type of thing you can think of, as long as it's hydrocarbon based. But remember, make a molecule only that's repurposed. So this allows our process to be much more simpler, much more robust. But what's really great about the product is that a lot of the refineries around the world want this. This is what they want. Yeah. Not trying to sell diesel fuel and compete with Shell or Chevron. And that's is where a lot of these PTF, plastics to fuel facilities that we examined were failing. They're technological success, but they're commercial failures. We stuck to make fuel that everybody wants, and it's a repurposed molecule.
Well, and that's what I think really, when we first started talking, really was compelling for me is you're just taking the original molecule and putting it back in it's the same form. If we can go into the plant actually, where we show the pyrolysis, which et cetera. And right now, again, as you said, you're not even using the pyrolysis. You're just actually using the heat to yield the condensate that you've done thus far. Can you take us through the diagram and how it all works?
Yeah. So once again, logistics, we're using rail to bring in our raw feedstock of bales. We're shredding it. We have our unique form of technology for washing the plastic. So we're getting the peanut butter, the mayonnaise, the blood, everything off that plastic and giving it a good wash. And then we're shredding it and getting it ready to almost like a cornflake. What's really cool is our reactor, says the kiln here, but it's a reactor. What we've been able to do is be able to take that physical plastic, regardless of what species, and be able to two-phase it into a vapor phase at a very low temperature. And that's unique. Unlike other rotary kilns, and you've seen it through other companies, they're running at 600 to 800 degrees C. We're running at 300 to 400. We're half the energy. And this allows us to take that vapor, and then once it's in that gas phase, because of our unique process with our catalytic processes, I call it our KFC spices, we're allowed to put this molecule back to a molecule from this to this, which is what the customer wants. So now this is a repurposed molecule. You can put it back into making more plastics, or you can go make styrofoam, or you can basically reuse it for all kinds of things. So this is why it's so simple. And allows us to make a zero sulfur green condensate. The byproducts that you get from this would be carbon black and the aromatics, and not everyone knows what those are used for. So you may want to touch on that. So this is the reject stream. So after we've taken our raw feedstock, made our finished product out of the bottom, what we've been able to do with our reactor is generate basically a black carbon that allows us to sell this to asphalt plants. This goes in for pigment, for asphalt, for color, but also we've been approached because it has zero sulfur in it. We've been approached by different companies to either make graphene out of it or reuse this for other applications such as tires. So we have a sales ability to sell this product, which is fantastic. So we're basically having no waste. Our gas is repurposed back to our reactor. Our reject stream gets sold to asphalt or to tires. And then obviously our main commodity product, which is the zero sulfur green condensate, we can repurpose to tons of different customers. So it's a real win-win-win story here.
Yeah, exactly. Then there's another, do you mind going a couple slides to the credits?
Yeah. There's our bit of a picture of our Primus pilot plant that you can see here. It's been heavily engineered. We've had tons of phenomenal, great people looking at it, in our team. We're really excited about our reactor. And then if you want to go, this is what's really great about it. You can see, obviously, we're making black carbon, zero sulfur condensate, aromatics, all kinds of species of plastic, drums, bags, film, don't matter. We take it all. And obviously, our plant itself is, going to be very small footprint, minimum amount of water. We're not exothermic, but we don't need a lot of power. And we've got some phenomenal safety built into our facility as well. But we also have an MOU with CN, which we're really excited about. Like, I can't stress it, logistics. When you're using these type of volumes, CN has been our biggest partner champion for us getting our plastic to the site. With these type of volumes, we couldn't ask for a better partner for our logistics partner at CN.
Okay, so let's talk about that, because plastic, feedstock is there's lots of it in the world. So this is why your relationship with CN is so important. Sourcing your feedstock. How difficult is that? And does it cost you anything? Are you getting it for free? Can you give us an idea on that?
Yeah. So there is a lot of free feedstock in the world. This is the stuff that doesn't recycle. Say, for instance, auto car parts. This is stuff that's medical waste. Agriculture is huge. Tons of waste. We're basically looking at CN with their depots, because CN's got all the logistics and all across North America. It allows us to have these depots with the bales being put in, say, for instance, in Toronto or even Lower Mainland BC, where we secured 200,000 tons a day of high density polyethylene, which was just basically like all the agriculture waste from all the tarps they put on the ground. So we had no problem sourcing raw feedstock. Absolutely. We're overwhelmed. It was quite impressive. So really good. We don't want to play with the subsidized plastic. The subsidized plastic with most governments is the credit is for milk jugs and pop bottles and stuff like that. That's kind of where their main focus is, but we're focusing in on plastics that you probably don't see and hear of.
Okay. And then obviously helps CN, like you said, because then they're not deadheading as well. They're able to bring something back.
Yeah, huge advantage. Huge advantage for logistics for CN. Their driver is they obviously want a green credit, so that if they're backhauling MTC containers from Toronto or Chicago, they can fill them up with bales of plastic, bring them to the plant. And this way it reduces their efficiency increases their efficiency, but reduces their carbon footprint. So they're more efficient in hauling. It's a real win for them as well as us. So I can't say enough good things about CN and how they've championed us for the logistics for all North America.
And a great key partner, really. For introductions to. Yeah. And then I think we should touch too on, everyone knows of carbon credits. It's been a very active market for, many years now. But in the last couple of years, plastics credits market has started up. Verra started, I think, the first one. And it's still in its infancy somewhat, and kind of a Wild West, like the carbon credit market was initially. But again, because the companies like Coca-Cola, Pepsi, anyone who produces plastic is they will be facing 30% fines in the EU. Same with California. So, and if you talk about PET plastic, the more you recycled material you use, the less effective it is, right? Because it degrades. So it's hard to make 100% recycled bottle. I think Pepsi tried to do it, was a failure. So there's this huge market developed for, for companies to buy offsetting credits to offset some of these fines they're going to face, or companies that just want to offset their plastic usage. And so,
and I think,
can you explain to us how the plastic credit market works so far and how they vet the plastic, et cetera, and quality, things like that?
Yeah, so we've gone down the road with Verra's. They've basically were kind of the pioneers of the carbon credits. Obviously, it's voluntary right now with the plastic credits. However, in Europe, they're much more, conscious about, credits. And we've heard some pretty large numbers coming out of Europe for plastic credits. One of the unique things about PlasCred, hence our name is plastic credits, is we want to be the gold standard. To do that, we have a third-party evaluation coming out with Verra to verify our process. This allows them to go back to Pepsi, Coca-Cola, Nestle, Procter & Gamble, all the big packagers of plastic that utilize it. And this allows them to say, we're certified. We can basically take that and show that we're repurposing that molecule back into the circular economy. That's huge. And that's where we think once we demonstrate these large volumes, which is unique to everybody, we'll basically be able to change and be able to start to become that gold standard in plastic credits. It's voluntary right now, but as you know, it's just like carbon credits were, this is evolving market, and it's been interesting to talk to the investment community. A lot of them are interested in more of the plastic credits than they are in the commodities. So yeah, stay tuned.
Well, yeah, I'm sure they are. Yeah. I mean, a lot of people made a lot of money, especially when the carbon credit market was started. And so
there's a little bit, if you look at this slide, this kind of shows the accreditation, the plastic credits, kind of the 1, 2, 3, 4, 5. So it's been done. Verra's doing it out of New York for us, and it's in play. We're also working with a very large producer, very large, and they've got their own ICSS Plus in here as well. So trust me, this is going to be a lot of fun. We're going to see how this shakes out. It's exciting. Here you can see the revenues. Year one, phase one, 2,000 barrels come on stream. We haven't put hardly anything in for plastic credits. It could be one day that the plastic credits are worth more than
your condensate.
Yeah. So time will tell. But right now, we wanted to have a meat potato, really strong financial. We make money. We're an ESG story that makes money. It's cash revenue. We want to make good EBITDA, solid. Our all-in costs, like today, for instance, we're trading with condensate at about $110 a barrel. Our op costs with delivery from, say, Toronto to site, process, labor, and finished product in the tank, custody and transfer, it's about $40 a barrel.
Not bad margins.
Yeah, really good. And we stress test this. We have a good team. We really want to err on the side of caution. So we've really, stress tested extremely well through our model. We're more than happy to share all that with any investor because we are excited with the fact that we have a finished product that makes money. We're an ESG story that'll make money. And that's a big difference. And
not 10 years out. And you don't need subsidies. Yeah.
We want first barrel right away. We want revenue. We want EBITDA. And that's where we're at.
And your plants, they can run 24 hours a day, 7 days a week?
Yes, absolutely. We can ramp up even higher. I think that's the big advantage why we are a great team. We've built these big mega projects for other big producers, $50 to $100 million projects, even billion. We know what it takes to get to those big scalabilities and debottleneck it, reduce field exposure, modular, put a good team out there, and because we want to get to first barrel. I mean, we want to start making revenue on this product. Plus, not to mention, be on the world stage by taking these huge volumes of plastics out of the ocean.
Yeah, it's a solution for so many problems and also money making, like you said. Don't think I have missed anything. I think we just should revisit the catalysts. So your next step is the feed study, like you said.
Yeah.
And how long will that take?
We're looking at a feed study on our site, probably less than 3 to 4 months. And that would be just to basically make sure we coordinate with CN and Feedstock and being able to work with our other vendors just to make sure we have a clear line of sight of exactly timing and everything we're doing. We're very particular on vendors. We are building everything from North American suppliers. We are working hard to make sure that there's no other, boutique things that allow to reduce times for build cycle. Our goal is to have a very smooth transition to get to first barrel.
Okay. So that's the other thing I was going to say. So no long lead items. They're all stock items pretty much.
Yeah. And that's another advantage of shopping in Alberta. We build refineries here. So a lot of the existing, I'm going to say manufacturers of refineries, they're really excited about this project. They want to be involved in this project. So I kind of feel we're an ESG story and an oil and gas story, but also we've got these great manufacturers that say, we want to be a part of this build. It's a real win for the environment, but it's a real win for to showcase that we've got the skill set here to really put our best brains forward and being able to show we can take huge volumes of plastic from around the world.
Can you go back to page 23 for just 1 second? There's a question here.
B3, okay. There we go.
Yeah, the graph. So with respect to year one, are we in year one right now, or is year one next year?
Year one will be next year. And it'll be next year, yeah.
Right. And then so after the patent you filed quite a while ago, from a few months. Yes. So we should be hearing on that. I know you're talking with many end users right now. And so that's will be a catalyst we're waiting for. And that will determine financing of your Maximus plant for the most part. Yeah,
there's been a lot of, for our customers, there's been a lot of producers, there's been a lot of even plastic companies, a lot of polystyrene companies. We kind of know the big names. They've been very keen on taking and doing their own third-party analysis on our fluid. They love it. They're excited. It's definitely a molecule that they want, and they can use it to make other products with. So that's we've even been approached by a very large plastics company to take their reject streams, because currently they're landfilling them. So which is exciting, because now we can offer them, we're repurposing it, we're recycling it. So we've got a lot of opportunity here. And, obviously our primary goal is to get to first barrel in EBITDA and start moving, because the technology works, it's scalable. We believe we will definitely be the largest plant in North America. We want to make something that all of Canada can be proud of and move forward.
Great. And I know you've had discussions with the Alberta government as well, and they're supportive.
Very much so. And that's one of the things, being in the heartland where molecule country is, it's a perfect fit. It's a perfect fit for all the customers in that area. It's just been a real win-win. We'll be providing, 40 to 50 good paying jobs as well, which, provides, good mill rates and boiler tickets, good quality jobs, a lot of good, obviously we're a safety culture for dealing with hydrocarbons. So it'll be a safe, good quality place to work. We're really excited about that as well.
Right. Well, it's such an exciting story. It's a complex story, though. I had to hear it a few times before I got it. So if anyone actually needs some further information or a one-on-one with Troy, happy to arrange. Thanks so much for your time and teaching us more about PlasCred. And we look forward to talking to you in the near future.
And thank you very much. And anybody who wants to see us, obviously, plascred.com. And I'd be happy to answer any of your questions. If you'd like to call and know more, I'm more than happy anytime to answer questions. Love what we're doing, and we're having a lot of fun doing it.
Yeah. Or you can reach out to me at jessica@adcap as well. .ca, and I will certainly help you assist a call or what have you.
Awesome.
Okay. All right. Thanks so much, Troy, for your time. Really exciting story, and looking forward to hearing more.
Thank you so much.
Okay. Take care.